Here we go. Where is it centered? It is centered at x equals 5. Centered at x equals 5. That's where it is for slightly obvious reasons, okay? Let's start the way we've been doing. So the limit as n approaches infinity. We're going to go through the ratio test. N plus 1 factorial, and then x minus 5 to the n plus 1 over n factorial over x minus 5 to the n. There we go. This is the limit as n approaches infinity of n factorial, n plus 1, and then x minus 5 to the n, x minus 5 over n factorial, x minus 5. Again, if you see things that cancel early on, feel free to go ahead and cancel them. Forgot the rest of my absolute value here. Whoa, I forgot something kind of important. Oh, cancel the wrong thing. Okay, here goes. Cancel the n factorial, cancel that. And we are going to go ahead and skip a step, may as well. The limit as n approaches infinity only affects the n factors. So the limit as n approaches infinity affects the n plus 1 here. And then x minus 5 is going to go right there. Oh, I forgot to put it in bars. I'll go ahead and do that. Leave the parentheses there just to kind of cover my mistakes. Okay, as n approaches infinity, this becomes infinity. This becomes infinity. Well, that means that the ratio test has shown that this series diverges. All right, it is not necessary for me to always articulate my thoughts like this, but I am going to write it out this time. This series diverges, and I won't write this part, but it's because the limit is infinity, which clearly is greater than 1. So this series diverges. However, well, let me back up before I say however. It doesn't matter what x value you plug in. I'm actually lying to you right now. I'm about to correct it. But it doesn't matter what x value you plug in. It's always going to diverge. You could plug in anything and it will diverge. However, based on the way that a power series is built, it's always going to match up at its center. So I have no idea what this function looks like. Who knows? You don't have to draw this, but who knows? It might look like that. And here's 5 right here. And I don't know how good of an approximation this is, but I know that it is never, ever perfect except at 5. It might be the worst approximation ever. It might be doing this. Who knows? It's probably not. It definitely isn't. But it will be correct at 5 because it's structured that way, because of the way these things work, because of Maclaurin, well, this was not Maclaurin, but Taylor polynomials, and the way it is structured to work, the fact that we use that point as the center and they will meet there. Even though the series diverges, any x you pick won't work except 5. So my radius of convergence, where does it converge? Well, it converges at 1 point. So radius is 0. So coming out from here, I would move 0 to the left or 0 to the right to find exactly where they meet, because they don't meet anywhere except at that 1 point. So when I talk about the interval of convergence, it's a really lame interval, and I'm going to write it as a sentence. The interval of convergence is x equals 5. That's it. That's not a very good interval. We're used to talking about intervals like, brackets and parentheses, but that's it. It's just that one location, that 1 point.